Given a quadratic equation, ax squared plus bx plus c equals 0, the quadratic formula is given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this works for all quadratic equations, including ones that have complex and imaginary coefficients, like the one that I have here, z squared plus 2iz minus 1 equals 0. Now my a here is 1, my b is 2i, and my c is negative 1. We're just going to use the quadratic formula. So we have negative b, negative 2i, plus or minus the square root of b squared, that's 2i quantity squared, minus 4 times a times c, all over 2a, which is 2 times 1. Now, 2i squared. 2 squared is 4, I squared is negative 1, so 4 times negative 1 gives us negative 4. This means that z is equal to negative 2i plus or minus the square root of negative 4. Negative 4 times 1 times negative 1 is positive 4, all over 2. Well, negative 4 plus 4, that's just 0, so that goes away. That means the plus or minus 0, that whole thing goes away, so this is all gone. We're left with negative 2i over 2. This means that z is equal to negative I. And that is the answer. Now let's take a look at an example that has complex coefficients as well as imaginary coefficients. Here, my a is I, my b is 2 minus 3i, and my c is negative 3 plus I. So let's use the quadratic formula yet again. It's given by z is equal to negative b, that's negative quantity b, which is 2 minus 3i, plus or minus the square root of b squared, that's quantity 2 minus 3i squared, minus 4 times a times c, and c here is negative quantity 3 plus I. Well, that's negative 3 minus I if you distribute the negative to both the 3 and the I, which is much easier to do in this case. And this is all over 2a, that's 2 times I, which is 2i. This is horrendous. So let's just take it one step at a time, and we should be able to get there. Here we have z is equal to, let's distribute the negative to both the 2 and the negative 3i. Here we have negative 2 plus 3i plus or minus the square root. Now let's see, 2 minus 3i squared. Let's do this off on the bottom here. That means 2 minus 3i times 2 minus 3i. 2 times 2 is 4. 2 times negative 3i is negative 6i. Negative 3i times 2 is also negative 6i. And then negative 3i times negative 3i is positive 9i squared. Well, here we have 9i squared is negative 9 because I squared is negative 1, plus 4 gives us negative 5. And then negative 6 minus 6i, well, that's negative 12i. Okay. So here we have negative 5 minus 12i in here. Let's get rid of all the stuff on the bottom, since we don't really need that anymore. Okay. Minus 4i times negative 3 is positive 12i. Well, that's actually pretty nice because that cancels out with the I, the negative 12i inside of the radical, and negative 4i times negative I, that is positive 4i squared, which is still negative 4. because negative 4i times negative I is positive 4i squared is negative 1, and 4 times negative 1 is still negative 4. And on the bottom, here we still have our 2i. Well, the negative 12i plus 12i, that cancels out. And negative 5 plus negative 4 is negative 9. So here we have z is equal to negative 2 plus 3i plus or minus the square root of negative 9 all over 2i. Well, the square root of negative 9, that's not so bad to compute. We need an imaginary number in there. That's just 3i. So here we have z is equal to negative 2 plus 3i plus or minus 3i all over 2i. All right? Well, this means that we can both add and subtract our 3i from the top. So that means that z is equal to negative 2. Let's see, let's try adding it first. 3i plus 3i, that's 6i all over 2i. And also, z is equal to, let's subtract 3i minus 3i. This is negative 2 over 2i. At this point, let's reduce. We can reduce this 2 right here because both negative 2 and 6 are divisible by 2. So here we have z is equal to negative 1 plus 3i all over I, or z is equal to the negative 2 and the 2, they can cancel out. Here we have negative 1 over I. Now, in Algebra 2, we are not allowed to have an imaginary number in our denominator. So to get rid of that I, all we have to do is multiply top and bottom by I. Of course, remembering to distribute that I to both the negative 1 and the 3. And the same thing over here, we'll multiply top and bottom by I. So now at this point, negative 1 times I, that's negative I. 3i times I, that's negative 3 because I squared is negative 1, all over I times I, which is negative 1. Or z is equal to negative 1 times I is negative I over I times I, that's negative 1. And finally, we can divide both of these answers by negative 1 to obtain z is equal to 3 plus I, z is equal to 3 plus I, or z is equal to I. And that is the answer to this particular quadratic. Thank you for watching.